Hi everybody, this is Mr. Folly. Let's see if I have my pen ready. I don't. Oh no. This is Mr. Folly, and welcome to the I Do You Do We Do 1.2. So we're going to go over what atoms are and what they do and all that other good stuff. So, oops. So atoms have three parts. I think you probably remember this from middle school: protons, neutrons, and electrons, right? So protons are in the nucleus. Protons are positive. Protons are called atomic number, or believe it or not, we throw this at you sometimes too, Z. Okay, it is a whole number on the periodic table. It determines the identity. Its mass is 1 AMU. It doesn't change when charge changes, and it contributes to mass. That's a lot of things about protons. Most important thing, protons are positive, and it's a whole number on the periodic table. Okay, it will contribute to the mass. So when we get to mass, remember, and you'll see this again, mass equals protons plus neutrons. And protons, I always abbreviate P positive. Okay. All right, neutrons. Neutrons are also in the nucleus. Neutrons are neutral, which means they have no charge. They're found by mass minus protons. Okay, so here I've got mass equals protons plus neutrons. So if I do a little math here, it is found by mass minus protons. So that means neutrons equals mass minus protons. But if you know one, you know the other. Okay, they have a mass of 1 atomic mass unit. A different number of neutrons, but the same number of protons is an isotope. That is a definition that gets lost from people, and people will miss that one. So keep an eye out for that. So what is an isotope? Same number of protons, but a different number of neutrons. That means same identity, different mass. Electrons are in clouds outside of the nucleus. They're rings in a Bohr diagram. Now, a Bohr diagram is a bad diagram, just so you know. It's got a lot of flaws in it, but we do use it enough just to kind of show they're not in the nucleus. Electrons have a negative charge. Electrons equal protons if you're neutral. So a lot of times neutral, that means it would be called an atom. Atoms are neutral. If it's an ion is anything with a charge. If I have a charge of +2, that means subtract 2 electrons. Isn't that weird? It's the opposite. If my charge is -1, that means add 1 electron. And they determine the charge. And electrons have 0 mass. Really, they have negligible mass. It's so small it doesn't matter. But for us, we'll roll with 0. Here is isotopic notation. The mass is on top. Look right here. Mass number equals protons plus neutrons. That would be 3. Protons are on the bottom. Remember, that can also be called Z. The symbol tells you the proton. So if I looked at the periodic table and I look at hydrogen, its number of protons will be 1. If I look at the number 1 on the periodic table, it will tell me it's hydrogen. Okay. Remember, electrons will equal the protons as long as there's no charge. The charge tells you how to find electrons. Notice we've got it again. -3 means add 3 protons. Oh no! Charge tells you how to find electrons. -3 means add 3. Oh, that's right, to the protons. +2 means subtract 2 to the protons. Anything with a charge is an ion and not called an atom or an element anymore. Negative ions, they have a different name. They end in "ide." So O-2 is oxide, not oxygen. C-4 would be carbide, not carbon. Positive ions are called ion. Calcium +2 is the calcium ion. Sodium +1 is the sodium ion. All right. So mass number is the top number, and it is not on the periodic table. Okay, it's related to it. That's the mass of 1. The periodic table tells you the average. All right. Regular nomenclature. It's a name dash mass. Name carbon dash mass is 12. Neon with 9 neutrons would have a mass of 19. So when I look at the periodic table, neon has 10 protons, right? So it has 10 protons plus 9 neutrons. That's going to be 19. So it's going to be name neon dash mass 19. If I have 32/16s, that means that mass is 32. And it would be name as the sulfur dash 32. Bohr model. Okay. The simplified model you've seen with many flaws. I'm going to just kind of ignore the flaw parts, but I don't want you to think that Bohr model is the best way to show an atom, because it's not. Protons and neutrons are in the nucleus. So if they're in the nucleus, looky, nucleus. Electrons are in rings outside of the nucleus. Really, they're in clouds, but that's okay. Rings hold 288, and we don't go farther than that. Okay, so let's take a look. Looking at this, I'm going to zoom in. Bohr model. It says, did I zoom in too much? I won't move it. It says protons 19. Why? Because it says 19. Neutrons 20. It says 20. Electrons 1, 2. I'm counting by ring. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So notice these are equal to each other, so it doesn't have a charge. And its mass would be protons plus neutrons, 39. Its name would be, let's see, what is number 19? Oh, I got to get my glasses to see it. Hope I can see number 19 far enough away at my periodic table. It's far away. It is potassium. Name, potassium dash mass dash 39. The isotope of it would be 3919. Okay. All right, let's look at the other one. Protons, hey, P, 5. Neutrons, 6. Electrons, 1, 2, 3, 4, 5. 5. That means it's neutral, no charge. Its mass is protons plus neutrons. 5 plus 6 is 11. What has 5 protons? That's my old friend boron. Dash mass, 11. And to show the isotopic notation for it, boron symbol is B. 11 is the mass, and 5 is the protons. And then that's it. So I will say to you now, toodles. Oops.